This is part 2 of section 6.1. We have just talked about our 3-row operations, okay? And what we're going to do is first, we have what we call Gaussian elimination. Gauss is how you say it, Gaussian elimination. And then what we're going to do is we're going to talk about this one, and then we're going to have something where this goes a little bit further, and it's called Gauss-Jordan elimination. We're going to get there. All right, so what do we want to do? We always want to start off by writing your augmented matrix, okay? So if I'm looking at this system of equations, I would write my matrix as my x values are 1, my y values are 2 and 1, and then the augmented part would be 5 and 3. So I start off with my augmented matrix. It's always my first step. Now what I want to do is I'm going to look at my goal. All right, sometimes we're going to have what we call a 2 by 2, because remember that's extra, 2 by 2, or we're going to have a 3 by 3. We're doing a 2 by 2 right now, and what I want to end up with are 1s on the diagonal and a 0 here, and then whatever happens here happens, okay? Now we need to take care of these in a specific order, or we're going to end up undoing things that we've already done, okay? So right here, I have the order written down. Now we're not ever worried about what happens right here, so that's why they're not included. The first thing you want to do is you're going to compare these. The first thing I want to do is to get a 1 in this position. The second thing I want to do is to get a 0 in this position. The third thing I want to do is to get a 1 in this position, okay? So if I look at this, the first thing I need to do is to get a 1 in this position, and I already have it. As you're going along, you may want to put a little check mark there because it will help you recognize that I looked at it, it's already what I needed to do, I can go on to the next step. Okay. Now, when we start listing matrices as we go along, these are called row equivalent. Not equal. Technically, you don't use an equal sign between them. You use a little tilde, a squiggle. Okay? Now, what do I do? So we have 3 row operations. We can switch any 2 rows. This is nice. It doesn't happen in every problem. It actually doesn't happen in a whole lot of problems. But you don't want to forget that it is an option, because sometimes your second equation is going to be exactly what you need on the top row. So you can just switch those. Now what we're going to be creating are 0s and 1s. Rule 2, where you multiply any row by a non-zero number, this is what we're going to use to create a 1. We're going to multiply by reciprocal. Okay? So we're going to, if we need to create a 1 in a step, we're always going to multiply by the reciprocal of whatever is in the spot that we need to change. Now, rule 3, this is the one that creates 0s. Now, remember, what I just showed you was the elimination method or the addition method. And our goal was always to get rid of a variable. And if we get rid of a variable, then its coefficient is a 0. Okay. So I have my 1. The next thing I'm supposed to do, step 2, is to create a 0 right here. So that means I'm trying to get rid of this 1. You can circle it if you want to. This is the step I'm on. This is what I'm trying to get rid of. Okay. So this is rule 3. We need to find what I call the tool row, and we're going to use it and put it back down without changing anything. Okay. Every time, every single time, you have to create a 0. Somewhere in that column, you have either created a 1 or checked to see that there is a 1. Okay? So even here, when you get a bigger thing, you will always have created a 1 before you need to create a 0 in that row. Okay? Wherever that 1 is, that's going to be your tool row. So this right here is my tool row. What do I need to multiply a 1 by so that if I add it to this row, it's going to go away? Well, if I multiply equation 1 by a negative 1 times row 1, and then I add that to row 2, it's going to give me a 0. I want to change this into a 0, so I'm going to put my answer where row 2 is. I'm going to replace row 2. Row 1 is not actually changing. Okay? Now I'm going to come down here to scratch paper and multiply row 1 by a negative. That gives me negative 1, negative 2, negative 5. This is the same as having an x, and I chose to multiply the first equation by a negative 1. Now we add them. 1 minus 1 is 0, and we should always get a 0 here because that was our goal. And then 1 minus 2 is negative 1. 3 minus 5 is negative 2. Okay? And all of this was rule 3. Okay? All right, so now we have, what do we have? We have our 1. We have our 0. And now we just need a 1. That's our last step, is to get a positive 1 right here. Well, you multiply by the reciprocal to get it. The reciprocal of negative 1 is always, when you're multiplying by reciprocals, you're supposed to get positive 1. So the reciprocal of negative 1 is negative 1. So I'm going to multiply. I'm trying to create a 1. I'm going to multiply by the reciprocal. I'm going to multiply negative 1 times row 2. And then I'm going to replace row 2 with that answer. So this becomes, I'm not changing my first row whatsoever. And now negative 1 times 0 is 0. Negative 1 times negative 1 is 1. Negative 1 times negative 2 is 2. Okay, so now we're done with dealing with the matrices. We have a couple more steps, but we're going to go back to some of the stuff we've done before. Compare right here. I have a 1, a 0, anything, a 1, anything, and anything. So I have it in the correct form. You want to create 1s on your diagonal. We call this the main diagonal. And then we want the bottom, what we call the lower triangle, or the left triangle, to be 0s. Okay, now what I'm going to do here is I'm going to take this matrix and go back to a system. If I rewrite a system with these coefficients, I have x plus 2y is equal to 5. Notice that I have exactly the same equation as I had here. And then I have 0x plus 1y is equal to 2. We are at the back substitution stage. Remember when we were solving systems, once we found one of our variables, we went and plugged it into another to find the other variable? Well, this is the same thing as x plus 2y, but instead of y, I write a 2, is equal to 5. X plus 4 is equal to 5. So x is equal to 1. The answer to this system of equations is 1, 2. Now, right now, I know that this seems tedious and long and sort of useless because you feel like you already know how to solve these a way that was pretty good already. Now, the good thing is about matrices is that it's very easy to program a computer to do them. That's one big bonus. The other thing is that this process will extend up to things where you have 4 equations and 4 unknowns, or 5 equations and 5 unknowns, or 10 equations and 10 unknowns. If you try to solve something that big with the methods we had before, you're going to get totally lost, you're going to make a huge mistake, and it's just a nightmare. And so that's when we really start to use matrices. But if you think about it, if you don't practice matrices with small systems, learning them in a big system is going to be awfully difficult. So that's what we're doing. Okay, so we have Gaussian elimination. Now, I only put down technically one example for this, and we're going to go into Gauss-Jordan elimination. Basically, what Gauss-Jordan elimination does is you get down to this, you'll get to Gaussian goal, but then you keep going. Basically, you keep doing the back substitution, but still in matrix form. So we're going to get practice with Gaussian elimination as we do Gauss-Jordan. Okay?